Ventilation fans either draw the air from the upcast shaft or blow the air down the downcast shaft. With few exceptions, modern mines have exhausting fans at the top of the upcast shaft to draw the air down one shaft through the network of tunnels underground and then up the other. Perhaps the most usual system is for the men and fresh air to go down the downcast shaft and the used air, coal and wastage such as stone from tunneling to come up the upcast. We've got our upcast and downcast shafts, so the next step is to drive the network of tunnels that will be the backbone of the mine. That earth movements have various effects on the seams, the simplest being tilting. The downward slope or tilt of the rocks is called the dip if you travel downwards, the rise if you travel upwards. The line of level working at right angles to the dip is called the strike, and it is along this that the main roads are usually driven. The workings then follow the seam down the dip, up the rise, or in some intermediate direction. Today, especially where main roads are used for local haulage, roads may be driven almost dead level at a number of different levels or horizons. This means driving through rock instead of keeping within the same conveyors and locomotive haulage available today. If the coal is there, the expense is justified by the results. So these level roads become the main arteries of the mine, with auxiliary roads or drifts connecting them to the seam. If you look at this layout of the colliery as it was before the Second World War, you will realize how better transport underground in the shape of conveyors and locomotives has revolutionized colliery layouts. Transport is the determining factor, but equally vital is the method of working the coal. In the early days, when the board and pillar system of mining was the most appropriate way of winning the coal, you might find this kind of layout. The board and pillar method of mining involves two operations. Firstly, roadways, known as boards and walls, are driven at right angles to one another, splitting the seam into pillars, which support the roof during the extraction of the coal. Secondly, the pillars themselves are extracted, starting with those nearest the boundary of the seam and working towards the shaft. There is a tendency to lose coal in this system due to the crushing of the pillars, especially as deeper seams are worked. Board and pillar working is still highly productive, while the overburden is not too great. But in deep mines, long wall working has to be resorted to, now that the shallower seams are worked out. In this system, the whole of the coal is extracted in one operation along a continuous face or long wall. In the long wall advancing system of working, the roadways are formed and maintained in the gulf, the area left where coal formerly lay, by building supporting packs as the face advances towards the boundary of the workings. In long wall retreating, roadways are formed out to the boundary through the solid coal. These roadways are then connected by opening up a long wall face between them, which is worked back towards the shaft. The coal is transported along the previously prepared roads, which are continually shortening as the face retreats. The great advantage of the long wall method is that 95 to 100% of the coal can be extracted. No other method of working is feasible at depth. So we have progressed from this kind of layout, where the coal was shoveled into tubs on the face, and the layout of roads was designed to avoid unnecessary hand pushing along the face. To this highly mechanized setup,